Hi, it's Jason Gorman from Codemanship with the sixth and final video in our series on test-driven development in JavaScript. This last video is going to be all about test doubles, stubs and mocks and that kind of thing. And I'm going to be demonstrating how we can use stubs and mocks to test drive a design that has external dependencies working from the outside in. So we're going to be covering here how to write unit tests that have external dependencies, but we're also going to be talking about how we can drive a design from the outside using stubs and mocks to essentially allow us to test one layer of our design without necessarily worrying about how the layers below it actually work. Okay, so this particular example, we're imagining a community video library where members donate copies of DVDs to the library. And when a DVD is donated to the library, when we add a new movie, there's a few things that need to happen. First of all, the movie is added to the library, but we need to fetch information about that movie directly from IMDb. So all we know when we donate a video is the IMDb ID. Let's assume that the user has looked that up online, the IMDb ID of the movie, and then we're going to fetch the information about the title of the movie, what year it was released, and what its IMDb rating is, directly from the IMDb API. Now, this, of course, is an external dependency. And if we want to write a unit test, we don't actually want to be connecting to IMDb because that's going to be complex and it's going to run really slow. We want our tests to run fast so that we can test the bulk of our code very, very quickly. So what we're going to be doing is we're going to be using something called a stub to return data that we would normally get from IMDb. A stub is going to be a function that from the outside works like the real thing. You use it like it's really going to connect to IMDb, but in actual fact, it's going to have a hard-coded implementation specifically to return whatever movie information we tell it to return. And that will allow us to test that this movie is indeed being added to the library. Okay, now we're going to start by writing an assertion for our test and working backwards. That's always a good idea. By the way, if you've not seen the first 5 or however many videos in this series, then I strongly recommend you go and look at those now and then come back to this because there's going to be a bunch of stuff that might not make that much sense to you. So if you've not seen them, go see them and then come back to this. Right, so we're going to assert, let's imagine that we've added to our library, which is just going to be a collection of movies. And we're going to look inside there and say there should be a movie in there now that has an IMDb ID that matches. So our movie ID should match our IMDb ID that we used. Okay. And let's do a deep equal. Let's do the whole thing. And what we're saying is that should be equal to now. I'm imagining that we have a movie that's going to be returned from IMDb. But we're also going to specify how many copies of that movie have been donated, which in this case, for the purposes of our test, is going to be 1 copy. Let's start working backwards from here. Let's create that variable there. It's just going to be an empty array. Okay. And let's imagine our ID is just going to be an IMDb ID. Now, it's all fake here. It's all make-believe, so it doesn't actually matter what the ID is because it's not real data. So we're just going to make one up. And this movie here is going to be an object. And this is going to be the information that our stub is going to return. What would be a good movie to donate to our video library? The Abyss. Excellent movie. What year was that released? 1989. And I happen to know that its IMDb rating is 7.6. So this is the information that our donate function, when we use it, is going to fetch from IMDb. So let's donate that to the library. So we're using the IMDb ID to fetch the information, and we're telling it there's exactly 1 copy. Okay, now, here's the thing. How is this donate function going to fetch this information? we're going to need another function that actually fetches information. So let's first of all just create this donate function. There's the ID, there's the number of copies. Okay, we need to fetch this information, but how are we going to do that in a way that we can substitute a different implementation of a function? How can we make it so that donate can call a function without actually directly referencing its implementation? Well, one easy way would be to pass a reference to that function in. Let's call it fetch. Pass a reference to that function in so that it can actually just call it directly. And then in our donate function here, what we're actually going to do is we're going to define an implementation of that literally just does one thing. Its job here is to return that test movie. That's all it does. And this is our stub. Let's just highlight it. This here is our stub implementation of fetch. All it will do is it will return the test movie that we told it to return. That's its only job, so that we can test that that movie information was added to the library. Now, if I run this, we can see at the moment it's not being added to the library. We're not finding it. So let's just write some simple code to add this to the library. And what we're going to do, it's going to be a copy of this movie. So whatever movie we fetch, we're going to copy that. And we're also going to add the number of copies to it. Nice, simple, trivial implementation, what's called an obvious implementation. I'm just going to do it. We run that, and now it's in the library. We've passed that test. Nice and easy. Nice, easy one there. So very important here, we are passing this stub implementation that returns the test movie that we told it to return. We're passing it into donate, and this is called dependency injection. Now, you might think that dependency injection is an object-oriented concept. Really, no, we can do that with functions as well. And the benefit of doing that is that donate can call this fetch function without knowing what its implementation is. So we can substitute different implementations, for example, a stub implementation. But that flexibility in our design allows us to do other things. For example, let's say we want to get movie information from a different source, like Rotten Tomatoes. Then we could substitute Rotten Tomatoes in there without having to rewrite this code. And that allows us to protect our internal logic from the details of external dependencies. A very, very powerful design tool. It allows us to write fast-running unit tests because we're basically faking these external dependencies using stubs and mocks, as we'll see in a minute. But we tend to find that the flexibility that allows us to stub and to mock functions also allows us flexibility in our architectures to substitute different external dependencies without rewriting our core code. So it's a very, very useful design pattern to follow. Very, very fundamental to good modular design. We have separated the concerns of how we fetch the information from whatever source it's coming from and what we do with that information once we've got it. Those are two separate concerns. And in our design, we can change one without having to change the other. That's really what separation of concerns means. How we fetch the information is somebody else's problem. So that's a stub. A stub provides test data. It looks like the real thing from the outside, but on the inside, it's just literally returning whatever data we tell it to return. That's its only job. Okay, now, I'm just going to try and make my life a little easier here for the next test. I'm just going to strip these out. Let's rerun my test as soon as I do that. Lovely. And you'll see in a minute why I've done that. Okay, we can make these constants as well. Don't need to be variables. So a bit more safety there. Okay, now, in the next requirement, as well as adding the movie information that we get from IMDb to the library with the number of copies that have been donated, we also need to send an email alert to all members about the new movie. So if I was a member of this library and someone donated their copy of the Abyss, I would want to know because I would want to borrow that. So we're going to send an email to all members. Now, this is another external dependency. Let's imagine there's an external email system. And again, we don't need to know how it works. We just need to be able to tell it, this is a very important word, to tell it to send the email. So we're going to use another test double, but it's different from a stub. A stub returns test data. In this case, it returns a movie. But this is a different kind of test double that allows us to write a test that will fail if one function doesn't call another function. So it's for testing the interactions between functions. So it's a different kind of test altogether. Now, how do we know if a function has been called? Well, if a function was called, its arguments collection would have been populated if it was a proper JavaScript function. So we could capture those function arguments, the data values that were passed in when that function was called, and use that to test whether the function was called and whether it was called with the right parameter values. So this time we're going to write an assertion first. This time our assertion is going to be about what arguments. Let's imagine we've captured those in an array here. What was the first argument that we would call this function for sending emails? And let's imagine we need to tell the email system what template to use for the email. So this is a new movie email. So that's the template it needs to use. Okay, working backwards from there. So just have that as an empty array for now. Okay, and we need to donate. Doesn't even need to be that, does it? Let's donate to an empty library. Again, the ID doesn't really matter. It's make-believe, but let's reuse our ID. And let's say we're donating one copy. And we need something that will fetch movie info. Otherwise, this isn't going to work. So let's pass our stub in here so that it works. That's going to return our movie. Now, we need, again, like with the stub for fetching movie information, we need a stub for sending emails. But this is a different beast. This stub is not going to return data. What this stub is going to do instead is it's going to capture arguments. So let's capture the arguments. Oh, it can't be an error function, can it, Jason? Otherwise, the arguments collection is not populated. So we're going to capture the arguments that have been populated when the function was invoked. There we go. Oops. Control decided not to work. Right, there you go. So it's going to capture those arguments when it's invoked. And at the moment, it's not being invoked, so it won't capture any arguments. So when I run this second test, no, let's run them all, please. There you go. So new movie is currently undefined because the arguments collection is empty. So all we need to do, strip that out into its own local variable, and let's call that movie. All we need to do is imagine that we have a sendMail function there that's being passed in, and we just need to invoke that function, and the right parameter value for that to begin with would be new movie. So that's the name of the template to use. Now when I run this test, we're actually capturing these arguments, and sendMail is not a function. Let's see what's going on here. We definitely are a function. Let's see if that helps. Nope, sendMail is not a function. Still doing it. This is jolly annoying. Now, here's something interesting that you might not have noticed. The reason this is failing is because it's invoking a function that's not there in that first test. Now, this is interesting because it means that we need to pass a function in, but we don't care about whether or not it's invoked in this first test. We only care about adding the movie that's fetched from IMDb. So this is a third kind of test double that we'll discuss in a minute. But what about in this test here that is now passing? What kind of test double is this? This is a mock function. It is a test double simply for testing that an interaction takes place. So all we're doing is we're capturing the parameter values, the arguments that are passed in when this function is invoked, so we can test that it is indeed called and it's being called with the right parameter value. And if it's not invoked, this test will fail. And this is what we call a mock object. Doesn't return any data. They're simply so we can test that that function is being called. So we can check that we are actually telling some system somewhere, send this email. And there may be other parameter values we need to pass in as well. We could go on to do those. So let's add a second assertion here. So let's imagine there's another parameter value. And in this one, we need to tell it who we're sending it to. So the distribution list is all members. And again, when we run this, it's going to fail because we're not passing that information in. Now we pass it in there. And it's passing. And then let's imagine finally that our email system, each template requires maybe one or more parameters. So the third argument that's passed in is going to be a list of parameters, which in this case is only going to be one. And let's make it a dictionary. So let's call this item in our dictionary movie. And then we're going to pass in the movie in our dictionary like that. Okay. So we've got one more bit of information to add, which is this. Oh, no, it's a dictionary, isn't it? Silly Jason. Okay, so there's our movie. That should pass. No, it doesn't quite work. What don't you like here? Movie, but was movie. Ah, deep equal. So we're actually examining an object here. So let's do that. Lovely. Okay. So what we have is a test here that requires that this sendMail function is called, and it's called with these parameter values. And if it's not, then this test will fail. And our fake version of the object of the function that we're passing in is called a mock. Essentially, its purpose is to capture those argument values and allow us to query them later. Now, mocks are very, very easy to do in JavaScript. Very, very easy to do. But there are mocking frameworks available as well. If you look on NPM, you'll find a few like Sinon and others. And so if you want to use a mocking framework to do this, you can. But what I've been finding as I've been experimenting with mocking in JavaScript is you don't necessarily really need one. Now, as you write more and more tests using mocks, you'll tend to find that there's a bit of boilerplate. This, for example, is usually always the same, and so on and so forth. So there's a bit of boilerplate that you might want to strip out into a small little library. For example, all we're really asking here is, do all the parameters values match and are they in the right order? So we could probably extract a function that loops through the argument values and checks them against what we expect them to be. And that kind of thing would be relatively straightforward to do. So those are the mechanics of mocks. Again, notice dependency injection. We're passing our mock into the donate function so that it can invoke it without directly referencing its implementation. So we get a real separation of concerns between adding things to the library and sending emails. In both cases, the email subsystem and the IMDb API, this code hasn't been written yet. It doesn't exist. So what I'm doing here is I'm faking it until I make it. I'm faking fetching movie information. I'm faking sending emails so that I can test the logic that's one layer above that. And this allows me to drive a design, quite a complex multi-layered design, from the outside in. And at each level, in each layer, I'm defining the shape of the layer below it. So we can see what, if we look at donate, we can see what this fetch function will look like, but we haven't actually written it yet. And we can see what this send mail function will look like, although we haven't actually written it yet. So we've defined what they do and what they look like from the client's point of view, from the outside. So we're still driving a design from the outside in. But what I would then go on to do once I've got donate working, which it currently is I would move on and say, okay, now let's write some tests for sending emails. Let's write some tests for fetching movie information. So we would move one layer in, if you like, into the design, onto the next level down, and start test driving those designs. And they may well have their own dependencies, and we may well choose to use test doubles, stubs and mocks, to essentially fake it until we make it for those things. So we can drive the design all the way through, defining at each layer from the outside what the shape of the next layer looks like. And what we end up with is not a bunch of unit tests written all from the outside, all for the donate function, but we may end up with some unit tests for fetching and some unit tests for sending emails as well. So at key points in our design, at each layer, if you like, there may be a bunch of unit tests that are testing at that layer, so that when those tests fail, we can be pretty confident that the problem is in that layer. So it helps us to pinpoint the tests, as well as allowing us to just drive a design directly from the outside in. It's kind of the best of both worlds. It is a very, very good design technique. Very, very good, particularly for large, complex systems that are made up of lots of different components that do different things. And it helps us to separate all of those concerns very cleanly using dependency injection, so that each layer doesn't know what's beneath it, really. It doesn't know who it's talking to. That is somebody else's problem. Okay, so that's stubs and mocks. They are a very, very useful tool for test-driven development. They tend to lead us to designs that have a cleaner separation of concerns. And those kinds of designs tend to be much easier to unit test. We can reach much more of our logic with fast running unit tests. But from an architectural perspective, it is useful anyway to separate those concerns. Now, there is one more thing I just want to mention before we finish this final video. This thing here. Remember, this test was failing. Let's just get rid of it for a second. This test was failing if I don't pass that in, because it's trying to invoke a function that isn't there. So there has to be something there. But it's not a stub, it's not returning data, and it's not a mock. It's not allowing us to test. It's not capturing the argument values. It doesn't allow us to test that this function is actually being called. It's just an empty box. That's all it is. It's just an empty box. And we call this a dummy. A dummy is a function that we need to be there in the test so that we can run the test and see them pass, but we don't care about it. So it has a dummy implementation. It does nothing. So stubs return test data, and we inject them into the function that we're testing, so that function can invoke them it can use them without knowing what their implementations are. And that makes them easy to swap with stubs and so on. A mock, strictly speaking, is not a stub. A mock is, again, a test implementation that allows us to test that a function is called and allows us to test what parameter values were passed in when it was called. So we can test that, for example, essentially that a message was sent to another function. Both are very useful for excluding external dependencies, but we can also use them to pretend to be things that we haven't written yet. We can fake it until we make it, and we can use that very powerful mechanism to drive a design directly from the outside, faking each internal layer below, moving through the call stack, if you like, moving through the layers, test driving each part without having to worry about how the parts it's connected to are actually working until we get there. And a dummy, finally, is something, it's a placeholder, it's an empty box. It needs to be there for the code to run and for the test to pass, but we don't care about it. So stubs, mocks, and dummies. Very, very important, very much the key to scaling up test-driven development to real systems that are complex, that have many layers, have dependencies, external dependencies like databases and web services. And it is the key to making TDD work on real enterprise systems. So there you have it, 6 videos, well 7 I think, I believe. One of them was a two-parter. If you're a JavaScript developer, I hope you've found this useful. It is not by any means the way. This is not the Bible of test-driven development in JavaScript. It's simply the way that I've been doing it. And I hope it gives you some ideas about how you might be able to apply these ideas to your code. If you're an object-oriented JavaScript programmer, if functional programming is not your thing, hopefully you can kind of get a feel for how this might be applied in OO programming as well. Very similar ideas, but we're not, for example, injecting functions, we're injecting objects. We're not testing functions, we're testing methods, and so on and so forth. So similar ideas, just a different syntax, but the same things apply. Okay, I hope that's been useful, and I look forward to seeing you again when we do JavaScript refactoring.